Hello everyone, in this video we are going to explain about the Python program that performs QR decomposition of a matrix using the Gram-Schmidt process. Let us deep downly discuss about the process of QR decomposition where the matrix are split into two matrices like Q and R. Where the Q is an orthogonal matrix, we know what is the orthogonal matrix in the common term, which means it's a column or perpendicular units vectors, and R is an upper triangle matrix. The relationship can be written in the form of A equal to Q into R. Let us now discuss about the program each by each and the step-by-step process. Now let us look at the code. The program starts with importing the NumPy library inside the function of QR decomposition. In the first, we are determining the size of a matrix using A dot shape. Two matrices then are created like Q, which is eventually holding the orthonormal basis vectors, and U, which is used to store intermediate orthogonal vectors. The process begins with first column of a matrix A, that is, column is taken as a first vectors in U, and it is normalized, meaning divided with the length. 2. The first column of a Q that gives the first orthogonal vector. This process begins with the first column of an input matrix A. This column is taken directly to the first vector is in U, which is normalized like we saw before itself, like dividing it with its lengths, and which will gets the orthonormal vectors, which will become the first column of Q. For the next column, the program applies the Gram-Schmidt process, which new columns starts as it is, and then we subtract its projections onto the previous computation vectors of a Q. The subtraction ensures that the new vectors is orthogonal to the earlier ones. Once orthogonal is achieved, we are normalized it, and this normalized vectors becomes the next column of the Q. In this point, we want to notice that this subtraction steps ensure the orthogonalities. In other words, this can be said like the new vector arrives, it will be not overlapping the old vectors, and once it's done, the vector is normalized and stored in Q. At this stage, we successfully built the orthogonal matrix Q. Next step is to construct the upper triangle matrix R. It is done using the interproducts. Each entries R square brackets of I comma j. It's calculated as a dot product of a column j as A and the column I as Q. Because of the way Gram-Schmidt works, it automatically gives us the upper triangle matrix. Finally, the program prints out the two matrices Q and R, which satisfies the relation A equal to Q into R. We see that Q into R is equal to A. We need to prove that it is nothing but QR decomposition process. Let us summarize the code. The code begins with input of matrix and using the Gram-Schmidt to build the orthogonal matrix. It is computed with the upper triangle matrix, and finally we get the output. With this, they are printing the QR matrix, and by satisfying the condition like A equal to Q into R. Thank you.